Hi everyone, Adesh here from Adesh Model Train. So today we will see how we can configure signals using REST API. So let's get started. First thing, we have to go into github.com/adesh-model-trains. Once we get into that, we'll go inside the repository. We have GMRA MQTT Spring Transformer Wireless Ecosystem repo. Once we get into that, this is a private one, but next week I'm gonna make it public. So once we get into that, we'll go into ESP Arduino solutions. So here we can see REST servo snap turnout signal. We can pick any of the REST implementation, REST snap turnout signals, REST servo turnout signals, or REST snap servo snap turnout signals. So we'll pick up this one. We'll download the source code. So let's do it on desktop. Code is downloaded here. Let's extract the code. So first thing what we need to do is we have to upload the code to UNO and ESP8266. So what are the things we need? We need ESP8266, we need Arduino, we need a bunch of connector wire, we need PEC9685 board, two LEDs we are using as of now, and this is external 5-volt power supply here. So let's upload the code first. So once we go into this, inside this zip, we can see Arduino slave turnout code. Let's open this code here. So we have to go into config. So we are not using any servo turnout, so make it 0. We are not using any snap turnout, we'll make it 0. Light boards, we need 1 for signal. Total number of board, we need only 1. Signal type anode, will make it true. Okay, so this is the thing, like if you feel like whenever after configuring it, if you feel like you're on the on command your signal is turning off, and on the off command if signal is on, then make it false. Do the adjustment, it means you have done the wrong configuration here. So this is the small thing we have to do. We are not using anything other than that. So let's connect the UNO. Let's select the port. Let's select the board type is UNO. Is yes, it's correct. Let's compile the code. Compilation is done. So let's upload the code again. Code upload is done. Let's see. So here we can see total number of PCF board for turnout and signal is 1. Total number of PCF board for servo turnout 0. Snap turnout 0. For light it's 1. And board number 0. Board address 40 with light and signals. So it will tell you what board address we have configured on index 0. So if you see, this is a board 0 on index, and it has an address of 40 because we have not soldered any of the address pins here. So we are good with this. Let's open the ESP code here. We'll get into this. We have to just change the wireless Wi-Fi username password, and this is the IP address of the machine where our Spring Transformer application will run, and that's it. So I guess we are good with this. Let's connect. So let's select the port 4020, select the board type. Whenever you are uploading the code, just make sure that RxTX pin are not connected to any of the device. So Usually in ESP it will take time to compile and upload the code. So compilation is done. Let's upload the code. Let's see. Okay. So once code is uploaded, it should be able to connect to Wi-Fi but not able to connect to the server, because server we have not started yet. So it should tell us that server is not reachable. The code upload is done. Let's see here what error message it should tell us. So connected to Wi-Fi, that's correct, but it should say that server is not reachable. Yes, error server is not reachable. That's okay. We are good with that. So let's close this. Keep this one aside. And first thing what we want to do is we want to just start this MQTT and Spring Transformer and then JMRI. So first thing what we will do, we'll start the MQTT server. We'll go into desktop MQTT config Python start. So MQTT has been started now, and to start the Spring Transformer, what we have to do, we have to go and get the command. So I have copied the tab, and then we'll go into Spring JMRI Transformer homepage, and here we can see you can pick any of the command whatever we want. Let's open the one more tab here, copy paste. Sorry, this should not work because we have to get into the right directory. cd spring. Yep, now this command will work, but before that let's check the configuration what we have given here in the YAML file. So we can use any of the editor. So node number 1, light count 0, 2 LED signal count 1, and light board 1. Rest we don't need anything, so we are good with the configuration. We can validate our configuration by pulling up the node configuration via REST endpoint. So this is good. We don't need this now. So here if we go into the bottom side of the same readme page, here we can get the all configuration here, or we'll just whatever the nodes configure it will tell for all the nodes, but we want only for node 1, so we'll just give the identifier here and we'll get the node 1. So here we can see node 1 is enabled. We have configured only 2 LED signal, rest everything is snap turn out and servo turn out is 0. Light board count is 1. Total number of turnout board required is 0. Snap turnout board required is 0. Total number light and signal board required is 1. Red LED we have to configure on JMRI 20001 on board number 0, pin number 0. It will send on signal, and board number 0, pin number 0, it will send off signal. For LED, green LED we have to configure 20002. Board number 0, pin number 1, on signal, board number 0, pin number 1, it will send off signal. So we are good with our configuration now. So next thing what we have to do is we have to just configure all these things together, and then we can now open the panel pro and we can test it. So now here you can see I have configured, let me show you yes. So now you can see we have configured ESP8266 with UNO via RX TX pin, and then 3 volt power supply, and GND is coming up from UNO itself. You can use UNO Mega whatever you want. And then this is RX TX pin, and if you see this is a PC9685 board where this is a GND and this is a power supply, 5 volt power supply, And this PC96 board we have connected via SD and SCL line, and this is 5 volt and GND going to the first board here. And from pin number 0 we have connected the red LED, and pin number 1 we have connected the green LED, and this is external 5 volt power supply. So short leg of both the LEDs are connected to the common GND, and long leg is connected to the pin number 0 and 1 from the PC9685 board. So next thing what we have to do is we have to change the network, and we have to start the Panel Pro and test the code. So now first thing what we will do, we'll just open the MQTT app. We'll just keep it here, MQTT app here. We'll just say connect. It will connect now, and let's minimize this. Let's open the Panel Pro. So here we can see everything, whatever we have saved, everything is created here, and Panel Pro is open. Just to debug that, we will select the port number for Uno and open the serial monitor window here. So this is good. Let's clean this one up, and let's open the tool table signal head. It will tell that server is not reachable because we have not changed the network as of now. Let's clean this up, and let's change the network here. So the moment network is changed, now this error will go off because now it's able to connect to the server. So that's the reason it was complaining again and again. Let's try the 2 LED signal first. So now we can see it's connected to network as well connected to server. So let's test the red light first. So red light is on. Let's check the green light. So green light is on, and let's check the yellow light. So in the yellow light, both the lights should be on because it is expecting that we are using multicolor LED, where we have to power up red as well as green to get the yellow color. So this is how we can do the testing, and let's see the dark. So this is how we can do the testing, and in the next section what we will do, we will just try to test. So 3 LED signals will be almost like this. I'll just create a short video for 3 LED signal, and if you like this content, please subscribe to my channel and stay tuned. Thank you.